All right, what is up, guys? Welcome to another video on prime logic. Today I've got a really interesting geometry problem for you today, which is, I think, a good and challenging one. So if you want to solve this problem, please pause this video because I'm going to solve this problem right now. So I'm going to solve this problem using two different approaches. The first one is a very step-by-step, gradual, an understandable way and approach. The second one is just using a formula which is just built for this specific setup and scenario. So whenever we have a right angle triangle and there is a square inscribed inside this, like in this setup, scribe with a side length on the hypotenuse, we have a formula for that. So first approach is a step-by-step guide. So we have a right angle triangle. This side length is 3, the whole height, and the side length is 4. This whole base, and obviously this hypotenuse will be 5. So let's name the side of this square as x. Let's name this angle as theta and this angle as alpha. And these three triangles, they are similar. For example, this bigger one, this is theta, and this is a right angle, this is 90 degrees. So these two triangles, this bigger one and this smaller one, they are the same because they both have theta. This is the shared one, and they have a right angle here, which is 90 degrees. So this one, the third one, must be also, for example, similar to this one, which is alpha. And the same goes with this triangle as well. So this triangle, right angle, and it is alpha, so they are the same, so this angle must be theta. So let's name, for example, this part as A, B, and C, and maybe some more names. So D at this point, D, F, G, H, so we don't need this part. So our approach is to try to find out the length of these segments, so AF and GB. So because we have the side length of this square, right? This FG is x. So if we can find somehow the side length of AF and GB in terms of x, then that's easy, because then we'll have an equation in terms of x, and then we can easily solve it for x. So for this approach, we can use some trigonometric values and relationships. So let's try to find out the tangent of theta in the bigger triangle. So what is a tangent of theta? Tangent of theta, or any angle inside a right angle triangle, is the opposite side to the adjacent. So using the big triangle, tangent of theta is 4/3, right? This is our first relationship. What about in this smaller triangle, ADF? So what is a tangent of theta here? So obviously that's beautiful, right? Because the opposite side is x, which is the side of this square. So tangent of theta, one more time, in the smaller triangle is opposite, which is x, to the adjacent. Adjacent side is AF. In other words, we can say AF equals x over tangent theta. So this is one relationship. And let's talk about the tangent of theta in this triangle. So let's name GBH. So tangent of theta, so they must be all the same, right? Because theta is just the same angle in all three triangles. So tangent of theta in this triangle, again, that's the opposite to the adjacent. Opposite is GB, right? Adjacent side is x, another beautiful relationship. In other words, x equals, sorry, not x, but we need GB. So GB equals x tangent theta. This is also another relationship that found. So now that's easy. So we have all these segments in terms of x. So let's write it down. AF plus FG plus GB equals 5, right? This is the hypotenuse of this bigger triangle. So we have the value for AF. AF is x over tangent theta. So x over 4 over 3. Okay, plus FG, which is x, plus GB, which is, okay, so x tangent theta. So tangent theta was 4 over 3. 4 over 3x. The whole thing equals 5. So let's bring it to the upper side and simplify this fraction. So we can write this fraction as 3 over 4x, right? So let's now find this common denominator, which is 12. So 9 over 12x plus 12 over 12x plus 16 over 12x equals, the whole thing equals 5. So 9 plus 12, 21 plus 16, that's 37, which is 37 over 12x equals 5. In other words, x equals 5 over 37 over 12, which is 60 over 37. So that's x, which is the side length of this square, and the rest is easy. So the area of this square equals 60 over 37 squared. So that's it. I think till this point, I think that's enough. And we don't need to calculate it further. So that's the first approach. Step-by-step guide using some trigonometric relationships inside. I'm sure there are multiple other ways. You could use different ways to calculate this one. So now let's go for a really fast approach. So I'm going to hold this part because that's the area, or maybe just the side length of this square. So let me wipe the whiteboard here, just a moment. So we found this was the side length of this square, right? But so we are trying to, that's going to be the second approach, which is a fast approach. So based on this, so this formula just works in this setup. Whenever we have a right angle triangle and there is a square inscribed on that, and the side of the square must be also on the hypotenuse of this right angle triangles. It doesn't matter which values are, so there is just a formula for this specific setup. So whenever you see something like this, the area of this square inside a right angle triangle and this specific setup equals A, B, C, which are the side length of this triangle, the right angle triangle. So A is, for example, the height, B is the base, and C is the hypotenuse, over A squared plus B squared, side squared plus AB. So there is no hypotenuse in the denominator here. And the whole thing, so this is just the side length of this square. And in order to find the area, obviously, we need to raise it to the power of 2. So let's kind of substitute the values here. So area of this square equals A times B times C. So 3 times 4 times 5, right? C was 5. So this is 12 times 5 is 60. So we found it 60 here. And A squared, so 3 squared, which is 9, plus B squared, which is 16, plus the product of those, so A times B, which is 12. And this is going to be 25 plus 12, that's 37. So we found the same thing. An area is this fraction raised to the power of 2. So that's going to wrap it up for today, guys. I hope you enjoyed this beautiful and challenging problem. I want you to drop your thoughts and opinions in the comments below, and also your own intuitive solution. So obviously these are not the only solution. There is a ton of other methods, and I really learn from you as well. So I want you to drop your thoughts and answers in the comments below. And don't forget to subscribe and like if you haven't already. And as always, I love you guys. I appreciate you guys. And see you in our next video on prime logic.